Welcome to Kanerika's podcast, The Digital Shift. Today, we're taking a deep dive into a scenario that is genuinely keeping enterprise executives awake at night.
Oh, absolutely. It is a major stressor across the board right now.
It really is. I mean, imagine signing a $10 million contract today for this brand new enterprise data platform, right?
Right. A huge commitment.
Exactly. And then you realize 3 years from now that you literally cannot hire the engineers to run it, or, your compute costs have just spiraled totally out of control.
Yeah, or even worse, your critical business data is legally trapped inside that specific vendor's ecosystem.
Yes, exactly.
Yeah.
And that is the reality that 90% of organizations are risking right now. Like by 2027, the vast majority of enterprises are going to adopt a hybrid cloud approach, and 92% are going to rely on multi-cloud strategies.
Which is just a massive, structural transformation for any business. And it really highlights this critical truth for enterprise leadership.
Which is what exactly?
Well, it is that choosing a data platform today is absolutely not just like a simple IT upgrade. It is not just buying software. It is a multi-year architectural commitment.
Right. You are laying down the foundation for the next decade.
Precisely. That initial choice dictates your future talent acquisition strategy, your migration timelines, and ultimately your organization's entire agility in the market.
The downstream effects are just staggering when you really think about
Yeah.
it. I mean, the integrations you build, the specific business logic you hard code into this system, all of that follows from this single decision.
Yeah, it creates a massive ripple effect.
So today's mission for our deep dive is to formally evaluate the big three enterprise data platforms that are dominating this space right now.
Yeah.
We are talking about Microsoft Fabric, Databricks, and Snowflake.
The heavy hitters.
Exactly. We are going to explore their core philosophies, their pricing implications, and how you actually navigate these architectural bets without succumbing to vendor lock-in.
Because that is the real trap, right?
Yeah. So for you listening, with multi-million-dollar investments on the line, how do you ensure you are adopting a platform that serves your business strategy rather than, altering your strategy to fit a vendor's product roadmap?
That is the definitive question, really.
Mhm.
And to answer it, we have to begin by examining the distinct architectural identities of each of these platforms.
Makes sense. Where do we start?
Well, understanding these core philosophies is absolutely essential before assessing their impact on a specific business outcome. So let's start with Microsoft Fabric.
Okay, let's get into Fabric.
If we look at its fundamental identity, Fabric is the ultimate consolidation play. It is all about bringing things together.
Let me pause you right there, actually. Because Microsoft was already a massive player in this space.
Yeah.
I mean, if I am an enterprise architect running on Azure, I already had data tools.
Yeah, you had plenty of them.
Right. So why did Microsoft feel the need to build an entirely new platform from the ground up?
Because the previous architecture, while it was very powerful, it was operationally fractured. It was very complex.
How so?
Well, prior to Fabric, a heavy Azure organization was dealing with an incredibly fragmented environment. You might have Azure Data Factory running your integration pipelines,
Okay.
and then Synapse Analytics managing your data warehouse, Power BI for your executive dashboards, and, Azure Data Lake Storage holding the actual raw files.
Wow. Okay. So you were essentially managing 4 or 5 completely different products just to get a single data workflow functioning.
Exactly. And each of those services had its own billing structure, its own security and access model, its own governance surface.
That sounds like an administrative nightmare.
It was a massive operational headache just to keep them talking to each other securely. So Fabric steps in and basically collapses almost all of that operational overhead into a single software as a service product.
Okay, so it is a single SaaS product now.
Yes. And the foundational piece of this new unified architecture is this shared storage layer called OneLake.
Right, OneLake. I hear OneLake frequently compared to OneDrive, but like for enterprise data.
That is actually a really great way to think about it.
But mechanically speaking, how does that actually solve the fragmentation problem? Like if an analyst needs data for a Power BI dashboard and a data scientist needs that same data for a machine learning model,
Right.
traditionally those require 2 entirely different formats, don't they?
Yeah, they do. And that is the structural genius of Fabric. It operates on what we call a single copy model.
Single copy.
Yeah.
Meaning what exactly?
Meaning under the hood, every single workload, whether it is data engineering, real-time analytics, or, business intelligence, it is all reading from and writing to a standardized open format called Delta Parquet, and all of that sits inside OneLake.
Okay, I think I get it. So you are completely eliminating data replication.
Exactly. No more copying.
You aren't extracting data from the storage lake, transforming it, and moving it into a proprietary warehouse format just so the dashboard can actually read it.
Precisely. The Power BI engine and the machine learning engine are reading the exact same physical file.
Oh, wow. That'll save a ton of money.
It dramatically reduces storage costs, but even better, it completely eliminates the data freshness issues that constantly plague those multi-tool architectures.
Because there is no lag time in copying the data over.
Right. If you update the file, the dashboard is instantly updated. It is perfect for organizations where reducing operational complexity is the top priority.
Especially if they are already deeply embedded in the Microsoft ecosystem, right? Like
Yeah.
using Active Directory and Microsoft 365.
Oh, absolutely. If you are a Microsoft shop, it is a very natural fit.
But okay, that makes total sense for a Microsoft-centric organization.
Yeah.
But what if a company is not all in on Microsoft?
That is a very common scenario.
Yeah, like what if you are running a multi-cloud environment across AWS and Google Cloud? And what if your primary strategic priority is, complex artificial intelligence?
Then your evaluation pivots heavily toward Databricks.
Correct.
Yeah, Databricks takes a very different philosophical approach. It was born out of the Apache Spark ecosystem, so it is purpose-built for heavy data engineering and production AI.
Okay, so it is much more engineering focused.
Very much so. Its entire foundation is built on open formats, specifically Delta Lake for data storage and MLflow for tracking machine learning models.
Okay, let's unpack that phrase open formats for a second. Because it gets thrown around constantly in this industry.
It really does, yeah. It has become a bit of a buzzword.
Right. So mechanically, how does an open format like Delta Lake actually prevent vendor lock-in? What is structurally different about where the data actually lives?
Okay, so think about a traditional legacy database. When you ingest data, the vendor's software transforms it into a proprietary format and stores it inside their closed system.
Like a walled garden.
Exactly. And if you ever want to leave that vendor, you have to run these massive extraction processes to get your own data back out.
Which takes months and costs a fortune.
Yes. But with Databricks and Delta Lake, the compute engine is completely decoupled from the storage.
Decoupled, so they are separate.
Right. Your data actually sits in your own cloud storage. So it is in your AWS S3 bucket or your Azure storage account. And it sits there as open Parquet files with a transaction log attached to them.
Wait, really? So if you decide to walk away from Databricks tomorrow, your data is still sitting right there in your own cloud environment.
Exactly.
Perfectly readable by any other system that supports open source formats. You don't have to extract anything because Databricks never actually took custody of it.
That is the immense strategic value of it. It provides organizations incredible portability across different cloud providers, which is, essential for that multi-cloud reality we discussed earlier.
The 92% stat.
Yeah. Furthermore, when you are dealing with advanced AI architectures like retrieval augmented generation, feature engineering pipelines, or multi-agent workflows, Databricks is highly optimized for that heavy processing.
It has the horsepower.
It does. But what truly sets it apart for enterprise use is a feature called Unity Catalog.
Unity Catalog. Okay, most platforms have some form of governance, right?
Yeah.
To control who can use a specific table of data. How does Unity Catalog differ from the standard governance?
Well, Unity Catalog certainly governs data access, but it goes much, much further. It natively governs the entire AI model lifecycle.
Oh, really?
Yeah. It governs the feature stores, the model lineage, the training data, all in one unified interface.
Which is an absolute necessity when you transition from just, experimenting with AI in a sandbox to actually running it reliably in a production environment.
Right, where auditability and compliance actually matter.
Okay, so we have Fabric for unified operational simplicity, and we have Databricks for heavy AI and multi-cloud engineering.
Correct.
That brings us to Snowflake. Now, historically, Snowflake revolutionized the industry by separating compute from storage.
They absolutely did. They pioneered it.
But today,
Yeah.
basically everyone does that. So if I am an enterprise architect looking at this landscape, isn't Snowflake just sort of resting on past laurels?
It is a very fair challenge, and I hear it a lot, but it really overlooks their current highly distinct differentiator.
Which is what?
Snowflake is currently the gold standard for governed data sharing at an enterprise scale.
Governed data sharing.
Yes. They allow live data sharing across organizational boundaries without moving a single byte of data.
I need to visualize this.
Sure.
Say a large manufacturer needs to share real-time supply chain inventory with an external logistics partner.
A classic use case.
Right. Traditionally, that requires complex extract, transform, load processes, right?
Yeah.
ETL pipelines. The manufacturer has to export the data, secure it, send it over an FTP server or an API, and the logistics partner has to ingest it into their own database.
Exactly. It is slow, it is brittle, and it is expensive.
So how does Snowflake bypass all of that?
Because Snowflake's underlying architecture was built from day one as a multi-cluster shared data system designed for secure multi-tenant access.
Okay.
So when you share data in Snowflake, you are not spinning up new infrastructure. You aren't creating network tunnels, and you certainly aren't sending a file over the internet.
Then what are you actually doing?
You are simply granting a cryptographic access policy. You are telling Snowflake that a specific external partner is authorized to point their own computing resources at a specific slice of your storage layer.
Oh, wow. So the receiving party just queries the live data directly.
Exactly.
It's like granting them a highly secure window to look at your database rather than taking a photograph of your database from yesterday and mailing it to them.
That is a perfect way to describe it. There is no export, there is no stale data copies sitting in a third-party system. And the best part is, the partner pays for the compute required to run their own queries.
That is brilliant. It shifts the compute cost to the consumer.
It does, and they have expanded this into what they call the Snowflake Marketplace.
What does the marketplace do?
It allows organizations to seamlessly publish and even monetize third-party data products. It is creating this frictionless data economy between businesses.
That structural ability to share without moving data is incredibly powerful. But, this brings up an interesting dilemma for us at Kanerika.
Oh, definitely. We see this constantly.
Right. Because if you have different departments needing different things, perhaps the engineering team wants the raw AI power of Databricks, right?
Yeah.
But then the business analysts demand the governed sharing of Snowflake.
Yeah.
And meanwhile, the executives just want the unified reporting of Fabric.
A very standard enterprise conflict.
Do you have to force everyone into one single system and just, accept the compromises?
Not anymore. And that is where we enter the interoperability reality.
The interoperability reality. I like that.
Yeah, enterprises no longer have to choose just one platform and create these isolated data silos. These platforms are increasingly building native bridges to one another.
Okay, let's look at how Databricks and Fabric interact then. How do they bridge the gap?
They connect primarily via the Delta Sharing Open Protocol and OneLake shortcuts.
Shortcuts again. How does a shortcut actually work technically? It sounds simple, but at a massive enterprise scale, how do you read a Databricks table natively inside Fabric without copying the data over?
So a shortcut is essentially a highly secure, intelligent pointer.
A pointer. Okay.
When you create a OneLake shortcut to a Databricks environment, the Fabric compute engine essentially reaches across the network and reads the Delta tables exactly where they natively sit in the Databricks storage layer.
Meaning a highly technical data engineering team can build pipelines and prepare complex data in Databricks, utilizing all that heavy-duty processing power.
Yes.
And then a business analyst can visualize that exact same data natively in Fabric's Power BI, all without any custom ETL pipelines bridging the two systems.
Exactly. You genuinely get the best of both worlds.
Wow. Now consider Databricks and Snowflake.
Yeah.
Because on the surface, they are fierce competitors, right?
Right, fierce.
But they interoperate too.
They do. They utilize a feature called Lakehouse Federation and Snowflake Iceberg tables to communicate.
Iceberg is another open format, similar to Delta Lake, correct?
It is, yeah. Apache Iceberg is an open table format that Snowflake heavily supports now. And the beautiful thing is Databricks can read and write Snowflake-managed Iceberg tables.
Which provides bidirectional governed sharing.
Exactly. Teams on each platform can work with data produced by the other without establishing a fragile custom data movement layer in between.
It sounds like instead of forcing all your international executives to relocate to one single corporate headquarters,
Right.
you have just given everyone a flawless, real-time, universal translator. They stay in the environment where they work best, but the communication across departments is instant and seamless.
That is an excellent analogy. You preserve the specialized, best-in-class capabilities of each platform while maintaining perfect organizational alignment.
That is huge.
Okay.
And similarly, Fabric's OneLake can connect directly to Snowflake via shortcuts and mirroring, right?
Yes, it can.
Creating a clean architecture where Snowflake acts as the secure, governed data layer, and Fabric handles the analytics and business intelligence presentation.
It is incredibly elegant when configured correctly.
But here's the massive reality check.
Yeah.
We have these three incredible platforms, and they can communicate perfectly.
On paper, yes.
Right. But how on earth does a massive organization, say a 50-year-old logistics company, actually move their ancient hard-coded on-premise data pipelines into this modern architecture?
The migration nightmare.
Exactly. Without operations just grinding to a halt for 2 entire years.
That is the exact friction point that stalls modernizations. And honestly, it is something we at Kanerika solve constantly for our clients.
It is what we do best.
Yeah. The manual work of translating legacy schemas and complex business logic into modern architectures is daunting, and it is almost always underestimated by leadership.
Which is why we utilize our proprietary migration accelerator. We call it FLIP.
Flip is a game changer.
It really is. So how does FLIP physically bypass that 2-year manual rewrite?
Well, we use Flip to convert existing pipelines from legacy tools directly into these modern platforms' native formats. Flip completely automates the translation of that complex logic.
So no human is sitting there manually rewriting SQL scripts for months on end.
Exactly. It ensures that as you move into Fabric or Databricks or Snowflake, you're doing so with optimized native code. It completely eliminates the massive timeline risks associated with enterprise migrations.
Automating that translation is critical. Now, assuming the migration is handled, we have to pivot to the long-term operational reality here, which is cost.
Cost is always the final frontier.
Because as these platforms share data easily, evaluating their pricing structures and overlapping features really becomes the ultimate deciding factor. So let's talk about the pricing paradigm.
Okay, so the primary shift you have to understand is that all three platforms utilize consumption-based pricing models.
Meaning you pay for what you use.
Exactly. You are paying based on the compute processing power you consume, not by licensing a fixed number of user seats like the old days.
Got it.
Fabric measures this usage in capacity units, or CUs. Databricks uses Databricks units, DBUs, and Snowflake uses credits.
The flexibility of consumption pricing is great, but, the numbers can scale dramatically depending on your architecture.
Oh, absolutely. They can scale terrifyingly fast.
Right. Because for an entry-level enterprise setup, you might see baseline costs around, say, $262 a month for a starting Fabric capacity, or maybe around $1,500 a month for a starting Snowflake deployment.
Which is very approachable.
Very approachable. But at a massive, large enterprise scale, you are looking at monthly spends ranging from $33,000 to well over $250,000.
Every single month.
Every month.
Which really highlights why stringent financial operations, or FinOps, over your compute, it's so critical. There are hidden pitfalls in consumption pricing that can absolutely devastate an IT budget if you aren't paying attention.
What kind of pitfalls? Give me an example.
Well, for instance, in Microsoft Fabric, if you do not manage your workloads properly, you can experience something called CU pool contention.
CU pool contention. What does that actually look like in practice?
So think of it like a restaurant kitchen during a busy dinner rush.
Okay, I'm with you.
If you have too many heavy queries, so the orders coming in fighting for the same fixed compute capacity, the stoves in the kitchen, everything just slows down.
Right. There are only so many burners.
Exactly. Your reports take longer to load, your data pipelines stall, and eventually the business is forced to purchase a larger, significantly more expensive capacity tier just to clear the backlog.
Just to get the kitchen moving again.
Yeah.
That is a great analogy. And what about Databricks? What is the major pricing pitfall there?
In Databricks, a very common misstep is the misuse of compute types. They offer what is called all-purpose compute, and they also offer jobs compute.
What is the difference?
All-purpose compute is meant for interactive, real-time development by a human data scientist.
Okay.
Jobs compute, on the other hand, is meant for automated, scheduled workloads running in the background, and jobs compute is significantly cheaper.
Why is there such a massive price difference?
Because all-purpose compute requires instant responsiveness and high availability for a human interacting with a notebook. They are waiting for the screen to refresh.
Right, the human time is expensive.
Exactly. But jobs compute can be scheduled and optimized for batch processing without a human waiting on the result.
I see.
So if a team runs their automated daily pipelines on all-purpose compute simply because they, forgot to switch the setting in a drop-down menu,
the enterprise is paying a massive premium for absolutely no operational benefit.
Exactly. You are paying luxury prices for background tasks.
That is painful. And in Snowflake, perhaps the most infamous pitfall I have heard about is simply forgetting to configure the auto-suspend feature for the virtual warehouses.
Oh, yes, the silent budget killer.
Because if your compute cluster does not automatically shut down after a period of inactivity, the meter just keeps running.
Precisely.
It is exactly like leaving the engine of a rented Ferrari running in your driveway all weekend while you are asleep inside the house.
Yeah, that is exactly it.
The meter is running, you are being billed for premium performance, but you aren't actually going anywhere. It charges you credits over the weekend while no one is even querying the system.
A perfect analogy. It just emphasizes that deploying the technology is only half the battle. Governing the consumption is where the long-term war is won or lost.
Absolutely. Now, beyond just managing the finances, we are also seeing massive feature convergence across the board, aren't we?
Oh, definitely. The platforms are aggressively copying each other.
Yeah, Snowflake recently added Cortex, which brings SQL-first AI capabilities directly to the data. Fabric has integrated Microsoft Copilots across its entire suite of tools, and Databricks has rapidly expanded its agent frameworks and natural language processing tools.
They are all racing toward the same goal.
So if everyone is converging and releasing nearly identical features every few months, does the platform choice even matter anymore? Or will pricing simply become a race to the bottom?
It is a highly relevant concern, but yes, the choice absolutely still matters. Feature parity on paper does not equal architectural parity in practice.
Say more about that.
While differentiation based purely on feature checklists is becoming much less durable, the true differentiators moving forward are ecosystem depth and integration.
Meaning, if your entire company operates on Microsoft Active Directory, Office 365, and Azure,
Right.
the deep native integration of Fabric provides a friction-free security and user experience that Databricks or Snowflake simply cannot match, even if they boast similar AI features on their marketing pages.
Exactly. Furthermore, the talent pool available on the market for these distinct platforms drives the decision. You really must choose the platform that aligns with your organization's core engineering competencies.
It is about the people, not just the tech.
Which ties perfectly into the final strategic insight here. Platform choice must be dictated by distinct business outcomes, not feature checklists or vendor marketing,
You have to ask what the organization fundamentally needs to be able to do.
and what it needs to stop struggling with.
That outcome-driven approach changes the entire paradigm from basic IT maintenance to actual innovation.
And honestly, this is exactly why we at Kanerika maintain certified partnerships with all three of these platforms.
Right, we don't just pick one horse.
No, we are a Microsoft Solutions partner for data and AI, a Databricks consulting partner, and a Snowflake select tier partner. Because our focus is squarely on AI readiness and ensuring the architecture actively serves the business outcome.
For example, deploying autonomous AI agents directly into these optimized environments.
Exactly. We deploy intelligent agents like Carl, which provides real-time data insights and analytics, and Alan, which processes, analyzes, and condenses lengthy legal documents.
But getting to that advanced state of AI readiness requires getting your fundamental data house in order first, which brings us right back to the staggering impact of the flip accelerator.
It always comes back to the data foundation.
Because when we talk about the immense friction of migrating legacy systems to these modern platforms, Flip delivers a 50 to 60% reduction in migration effort.
It is massive.
We're talking about shrinking a huge 2-year manual code-based migration into just 90 days. And that speed translates into real, measurable ROI. Like the $1.2 million in average annual cost savings we achieve in our logistics operations deployments.
It is really about removing the technical friction of modernization, so enterprises can actually realize the value of their data faster, rather than just being bogged down in endless migration cycles.
Well, we have covered a massive amount of ground today.
We really have.
We went through the core architectural bets, the new reality of native interoperability, the intricacies and pitfalls of consumption pricing, and the absolute necessity of aligning with tangible business outcomes.
It's a lot to digest.
It is. But to leave you with a final forward-looking thought to explore on your own, as autonomous AI agents become fully capable of writing, optimizing, and executing their own complex data queries across any format and any system,
Yeah.
will the underlying platform brand even matter in a decade? Or will these massive data platforms simply dissolve into invisible infrastructure, silently powering the business from the background?
That is a fascinating question for the road ahead. The technology is moving fast, and that invisible infrastructure might be a lot closer than we think.
It really might. Thank you for joining us on this deep dive. Till next time.